Hey, Andy here. In case you haven't been paying attention, there's this new trend out right now called AI or artificial intelligence. But what I wanted to do is really kind of take a little time and kind of highlight how we can use Harvester to present GPUs to virtual machines to really kind of act as a foundation for any kind of AI work you may be doing or want to potentially use. So kind of a fun little thing with the hardware I've built. So I found a YouTube video from a guy named ETA Prime where he was using an Minis Forums MSO1. So I actually have one, and I'll show the photo in the video in a second. But I took a fully loaded MSO1 with the 13900H chip. I slapped an RTX A2000 12 gig card in it, and it's a perfect size card to fit in this little tiny desktop. Like I said, I'll show a video here. And what it really allows me to do is kind of keep a very small footprint and potentially travel with it and show customers that the GPU and Harvester and a virtual infrastructure with Kubernetes can be actually portable, which is pretty cool. Okay, so I've already got it deployed. I've got Harvester installed. I've got, by the way, this will be in the show notes. No, we don't need to read. I can leave it there. This will be in the show notes, but I basically have a YouTube video where I go over installing Harvester 1.3 and all the basics. What I want to do now is kind of pick up from there and then show how do I do a GPU pass-through, PCI pass-through into Harvester with a VM. And we're going to go soup to nuts. I'm going to pause the video a few times just to make sure I don't bore you to death, and this video isn't like an hour and a half long. But then at the very end, we're going to have a fully working Ollama and even a web interface to get to it, which is pretty cool. Okay, so let's start with Harvester. So here's a basic install of Harvester to show you. I've even named it MSO1 because I'm simple like that. Actually, the MSO1 is perfect. It's got multiple 10 gig ports if I ever wanted to upgrade the networking. It's got several NVMe slots. Right now, I think I just have a 2 terabyte. Yeah, I have a 2 terabyte NVMe and 64 gigs of RAM. So pretty straightforward. One of the things we need to do to enable pass-through is go under here under PCI devices. And then the first time you come in here, there'll be a statement that's saying it's not enabled. Click to enable. Click that, wait about a minute, refresh the screen, and now you get presented with this. Okay, and these are all of the PCI devices that the MSO1 sees. Now notice I have 2 right now that are enabled. One of the interesting things, and I'm not sure if it's true, I haven't tested it, but when you present a graphics card, you'll also see an audio device, which is the HDMI audio pass-through for the card. Go ahead and enable that too, because I actually present both of those to the VM. I've heard some issues with some of the cards and some of the drivers that if one's missing, like if the audio is missing, then the graphics won't work right because it gets confused. So just present both. What you can also notice though is I've got several Ethernet controller 10 gig SFP plus adapters on this MSO1. So this could be another interesting way to take a VM and give it straight to a network, give a network card directly to a VM, and then run whatever workloads there that you want to do. So it's really kind of cool to be able to do this. I know future looking, USB is going to be an option at some point in the future, but also Thunderbolt uses PCI over the protocol. So you could use today Thunderbolt 4, Thunderbolt 3 to get PCI devices shared. Okay, cool. I've clicked them. I've enabled pass-through for them. We don't need to do that for the NIC. What I can do now is let's go ahead and build out the virtual machine. And let me show you what that kind of looks like. So what I'm going to do is I'm going to go ahead and create a VM, and I'm going to use, we're going to call it AI video. I'm going to use my Rocky template. So basically it just sets up a couple little things like the networking, the storage, the boot device. What I'm going to do is I'm going to take this up to 8 cores and 16 gigs of RAM. I'm going to do my volume instead of 160. I'm going to do 120. Reason being is the Ollama is what we're going to be using. Ollama models are relatively big. They're 5, 6, 7 gigs a piece. So it's a good idea just to bump the storage up. And then notice I've got PCI devices on the left. Now, because I've already enabled them, I don't need to worry about the bottom part. I can go here and just select the card and the high def audio controller. So remember, I couple them. I've heard stories. Doesn't hurt. So I'm going to go ahead and click create. And that'll take a second to create. What I'm going to do is I'm going to go ahead and spin this. I'm going to pause the video. I'm going to spin this up. I'm going to log into it. And then I'm going to run DNF update, and I'll come back with the VM up and running and the kernel update, because I know there's a kernel update for Rocky 9.4. Okay, see you in a minute. Okay, and we're back. It only took about 4 or 5 minutes, maybe 6, 7 minutes, a short period of time to go ahead and get the VM scheduled on the node, bring up the SSH into the VM, and notice I did a DNF update. One of the other things I also did just to kind of streamline this video is I created some DNS entries, and I vimmed, here, let me exit it. I vimmed some Etsy hosts. Just go ahead and add them in just to kind of simplify things for the GUI. Okay, so now I'm back in my VM. And what we can do, and by the way, here's the VM running. We can go within Harvester, I can go look at the console and things like that, which is kind of nice. And we can see the resources being used. This guide will walk you through all this stuff. So far, we've got our V up and running on our MSO1 with our A2000. What I'm going to do now is I'm kind of following along here for the VM setup is I'm going to do some kernel tuning. This came out of years at Docker. Don't ask me why, I just do it every time. What I'm going to do now is I'm going to go ahead and install the CUDA drivers from NVIDIA. So the process basically is install the OS drivers, then install RKE2 for Kubernetes, tell RKE2 about NVIDIA, and then run the GPU operator from NVIDIA that kind of closes the loop and seals everything up. Some of this might be might overlap. I haven't done extensive testing to find out the absolute bare minimum, but I know this is repeatable and will work. So I'm going to do is I'm going to copy this block. So again, we're adding the yum repo, we're DNF installing some nice to haves for Longhorn, and then the kernel modules for the NVIDIA driver. So go ahead and do that. One of the other things that's going to output is an LSPCI. So we'll actually be able to see in the VM that from a PCI standpoint of view, it can see the video card. You know, if you're looking at troubleshooting steps, this is a really good one to kind of, if you don't see that card, to go ahead and stop what you're doing, back up, and make sure that the card is seen. LSPCI is going to be a great way to do it. That's with the PCI utils package. Yeah, I'd make sure the card's seen by the VM. The other thing is you can go in here. You in Harvester, you can go, I'm going to edit the config, but I'm not going to save it. And then just go under PCI devices and validate that you see those two devices there. I'll go ahead and cancel that. I'm going to pause real quick while this is updating because this will take another 5 minutes. And I'll be back on the other side. Cool, we're back. Okay, so we can see from the LSPCI that this worked. We've got Helm installed, and we can do LSPCI, not CPU, rep-i. Right, we can see that, cool. We now see NVIDIA card in the OS. By the way, I forgot to tell you, I'm actually running Rocky 9.4. A lot of my customers are RHEL-based, so binary compatible, all the great things. But the other interesting thing is this is also going to have SE Linux and enforcing. So we're going to install RK2 in a minute. It's going to be fully stigged, almost fully stigged. There's one little caveat, but almost fully stigged, ready to go. So this is kind of checking a lot of boxes at once, which is pretty cool. Okay, so we installed the RPM, the repo, we installed a bunch of packages, kernel modules, we validated the card is seen by the operating system, and we installed Helm. Great. Let's go ahead and install RKE2. So what we're going to do is we're going to go ahead and do a user add, make a bunch of directories, install a config file, and then actually go ahead and install it. Yep, go ahead and do that. And then we're going to go ahead, when that's done, we're going to go ahead and do symbolic link and kubectl get notes. So I'm just going to copy the whole block. Why not? Let's YOLO this. As you can see now, it's installing the RPMs from the curl pipe bash. This may take another minute as well. While this is running, one thing I do kind of want to highlight in terms of operating system is that the NVIDIA GPU operator does have the ability to automatically install the drivers into the base OS for Ubuntu. It does it really nicely for Ubuntu. Unfortunately, it doesn't work for air gaps. It doesn't work for some of the Rocky Rail-based ones right now. So that's kind of why I went the path of installing the driver ahead of time and layering it that way. It just made more sense to me especially with portability, like with our tool hauler, or going into air gaps or disconnected networks. So it just logically makes more sense, right? Install the driver in the OS, then Kubernetes, then the Kubernetes operator, go. Cool. We'll give this a second to come up. What we will have to do, because the next step is we're going to go ahead and have to tell RKE2 that, like, hey, by the way, there's an NVIDIA runtime. So here's the important piece right here. There's the NVIDIA runtime, that it is an additional option that's available. And oh, by the way, here's the actual binary for the NVIDIA runtime. Because NVIDIA locks their stuff down, you have to use this other runtime in order to execute against the GPU. But the cool part is it just means I just need to go ahead and edit this file. So I'm going to go ahead and edit the file. I'm going to paste it in. Let's see if our node comes up. Get node. Learn to spell. Cool, it's ready. What we're going to do now is we actually have to restart it because, again, we just modified the configuration file. So we're going to restart RKE2. Okay, that shouldn't take. There's not a whole lot running there. When that comes back up, then we're going to be able to take advantage of Helm to add in the GPU operator. And then we're going to go ahead and deploy the operator. And notice right now we're saying, hey, operator toolkit, here's that TOML that has a definition for the runtime. This is how you get up and going. The other two things I want to add in is, see how it says driver enabled false, toolkit enabled false. This is because we've pre-installed those things, so we don't want it to try and do it as well. So go ahead and add the Helm chart and then run the GPU operator. kubectl get pod-n GPU operator, and you can see things are coming up, and we can do -w for a second and watch them create. One interesting thing is my MSO1 is on my home network. I've got a gig up and down, so it should be relatively quick to pull these images down. And see, it's already starting to pull things down, which is awesome. Great. I'm going to let that run in the background. We can actually move on to stateful storage. So I like adding stateful storage, especially for some of the applications. And we know that Llama and Ollama on the Open Web UI does take some storage, especially for those large models. So what I want to do is I want to add a Longhorn. So that gives me persistence, a PVC class. I could use host path. I could use a bunch of different things, but it allows me to just use this out of the box. So what I'm going to do, remember I said I edited my Etsy host. I'm just going to go ahead and create that domain name because I'm going to use it multiple times. The first thing I'm going to add is Longhorn. So this is our stateful storage layer from Rancher, and this will give me the ability to again provide that persistent storage. So we can see that doesn't take as long to come up, and we can see that some of them are already coming up. And then we can do while we're here is we can look at the GPU operator. So this will take a minute. It's got to go through its init process, but it's validating device plugin daemon set. That should potentially error out and go away because we don't actually need that because that's the plugin. There's also a driver device driver that'll run as a daemon set that we don't need. Okay, cool. Longhorn's up and running. And because I used longhorn.rfed.me, we can see it's already up and running. We've got our node, AI video, right? That matches with our VM. We can see that there's no volumes. In fact, we can leave it on this and we can come back and look at this later. Great. So I got Longhorn up and running. Let's just double check the GPU operator. And cool. We're gonna have to probably give this a minute or two to finish its init process. What I want to make sure is that the operator has done what it needs to do to make sure the Kubernetes can talk succinctly to the GPU. While we're waiting for that real quick, I'm going to go ahead and do these two Helm repo adds. So this is adding the Helm charts for Open Web UI and Ollama. Let's get the pod. Okay, I'm going to pause right here and we'll come back in a minute or two. Again, this will probably take a minute or two to finish its initialization. And see you on the other side. Okay, we're back. Turns out I skipped a step. Now, I've already updated the documentation to kind of highlight it, but I skipped a reboot. And I think this is what's kind of important. When we go through and install the RPM repo, Yum repo, we install the drivers. We should have rebooted. I think that was what was causing the issue. So I just, behind the scenes, off camera, I went and rebooted the node. Now the operator looks good. The toolkit's there. We can get pod everything. We can see everything's up and running just as we'd like. Great. Awesome. Good times. Now, what we can do is now we can actually go, we've got Longhorn and NVIDIA done. Let's go down here. Now we can actually go, we've added the 2 Helm repos. I'll add them again for giggles. Okay, they've been added and updated. Now we can actually go and install Ollama. So the way Ollama works, too much there. The way Ollama is going to work is that's the underlying AI, and then the web UI is going to interact with it. So we'll go ahead and deploy. Oh, forgot my domain name. Domain equals rfed.me. We'll deploy that. Cool. And we can do a get pod, and we can see that it is running. Great. What's kind of interesting, kubectl describe pod. And I'll just copy and paste that one. If we describe the pod, I want to point something out which is kind of cool. So one of the things, there's a bunch of annotations and labels. There's also a resource, and we will see that it creates a resource of NVIDIA GPU 1 with a request of 1. So GPUs are a schedulable, requestable resource within Kubernetes and RK2, which is really good if you're dealing with servers that have multiple GPUs. If you're lucky enough to take advantage of that. Okay, cool. We can go get our pod, and we can see it's up and running. Now, what's kind of interesting is I've got in this doc, I've got it set up to actually present a web page. And so if we go to ollama.rfed.me, what we'll do, see, I was looking at why they get stuck. Cool, we fixed it. So it's actually saying Ollama is up and running. And it listens on port 11,434. But we can also see if we come back here, there's no stateful data. I thought I had stateful data on this. Persistent volume size. That's odd. I'm curious why that didn't show up. Huh. Must have pasted it wrong. No worries. Here we go like that. Make sure we get the whole thing. Let's see if it redeploys it. If not, I'm not going to worry about it. Huh. There might be a bug in the... I'll have to double check that off camera. We'll definitely fix that. But now we've got that up and running, as we can actually deploy Open Web UI. And that's our... Control C. That's our GUI. And similar, we're just telling it where Ollama is and persistent storage, and go from there. So we can do kubectl get pod. And now we can see that's pending. That should take a sec to deploy because that doesn't need GPU. Yep, creating. And we can go look PVCs. Okay, so that one's working. So I must have messed up the syntax on the Helm command. No worries, that's easy fix. And we can go to Longhorn so you can prove me right. The reason why it's in a degraded state is because it wants to have 3 replicas. We can click on it. It wants to have 3 by default. I've only got a single VM, so that's why. It's not a big deal. We'll go back here. We'll leave that be. Notice it's Open Web UI is pulling up a 5 gig, right? So that matches, which is cool. Close that out. We actually don't need this anymore for the Ollama. Let's go see if the pod's up. Still creating. It might take another second or two. One of the things that we're going to go into, and hopefully we're going to configure it and show you real quick, is that Ollama allows you to actually import multiple models. So they have a models page, which is pretty cool. For this demonstration, I'm going to use Llama 3. Yeah, because that's not confusing. I'm going to use Llama 3. There's another one for code. What is it? Maestro. And then LL Lava is a good one for pictures. So obviously, the different models can do different things. But for this, I'm going to use... maybe we should use Gemma. Yeah, we'll use Gemma. Why not? Let's see how big it is, because I haven't used Gemma. I've used Llama 3. So it's 5 gigs for the 7B model, which is the latest. Cool. So we use Gemma. Why not? Okay, see where we're at. Still creating. Okay, it's pulling down. We'll give that another minute. In fact, while we're looking at it, let's look at the Helm chart. Let's look at the Helm. Create namespace, set runtime. So that's an important one to tell us we're using NVIDIA. GPU enabled true. Persistent volume enabled. Set persistent volume size. Huh. That should have worked. I'll test this off and put a note in here. And then I go to the ingress stuff, path prefix, what the ingress name is. Cool. Now OpenWebUI is up and running. Let's go ahead and get ingress. Oh, that's not going to work. kubectl get ingress-a. So we're doing webui.rfed.me. We'll open up a new tab. Boom, we're in. Now, one of the things we can do, potentially if we want to script this, did I add it in here? No, I did. So if you want, you can go ahead and run this URL, this curl command from your host. And what it'll do is it'll create an admin account, or you can simply type sign up. Let's go ahead and do sign up. But what you can do is do your name. My name is, I'm going to be Captain Admin. Why not? Captain Admin. Admin at rfed.io, PA22WRD. And I'm going to go ahead and hit create account. So cool. Now I'm the admin. Woohoo. I am the first one to log in. And what we can do is we can go to settings. We can look at connections. The first thing I like doing is validating the Ollama API. So I'm going to hit the verify connection. Green is good. Yes, we can talk to the Ollama pod. Go to models, right? And don't worry about the models here. What I'm going to do is I'm going to type Gemma, and I'm going to hit download. Ooh, excuse me. And what this is going to do is this, see how it's downloading the model in the background. Okay. It's taking a minute. Okay. Once that's done, we don't need to delete a model. We'll give that a second. But once that's done, we will now have a command line interface with our own, aka ChatGPT, using the Gemma model or the Llama 2, Llama 3. You get to decide, obviously, here which model. And again, the models, there's a link up here for the different models. So the Ollama models, the Helm chart, and the OpenWebUI chart if you want to take a look at it. And again, we looked at the Gemma. 100% and save. Come on. I'm going to tell you right now, this is pretty addictive. This is where you start to be like, great, I need a bigger machine. I need more GPUs. I need an RTX 4090. I need that. I need. And it's like, okay, no, this doesn't quite work. So the way you can work in the interface, so Gemma and, what's a good one? What is Rancher? RKE2. And we can see now that in the background, it does take a second. Maybe Gemma doesn't know about it. Wah, wah. There we go. Okay. One thing we can do in the background to keep me honest, we can run the NVIDIA SMI and see that we're at 99% GPU rate, which is pretty cool. And we can, within a few minutes, we've got Harvester GPU pass through, Rocky in SE with SE Linux enforcing, running RKE2 stigged, Ollama as the AI interface, WebUI running our own locally. Because apparently ChatGPT went down yesterday. Now you can see how cool this is in terms of portability and managing your own infrastructure. I hope you found this interesting. I'll obviously have a link for this GitHub repo in the show notes. Let me know anything else you want to see. Like, share, subscribe. You know how that works. And I don't know, go back. Thanks for watching. Bye.